Before watching this video, if you haven't already, please make sure to watch my video covering Indices 1. It should appear somewhere in the top right of your screen while I'm talking. I highly recommend you guys to watch it if you haven't, as it will be a major help to understanding this video. Okay, so hello everyone and welcome back to another video. In this video we're going to be continuing on from Indices 1 and going into Indices 2, where we're going to be going over fractional indices and exponential equations. So the first thing we're going to do is, just as a recap from Indices 1, as a reminder, is the first thing is when we are multiplying two indices together, so what we do is we add them. So if I have a times a to the power of m times a to the power of n, that just gives me a to the power of m plus n, so we add the indices. And then when we're dividing, it's the exact opposite. So if I have a to the power of m divided by a to the power of n, it's just a to the power of m minus n. And then when we're raising to a power, when we have something like this, when we're raising to a power, that is just going to give me a to the power of mn. So you multiply them together. And finally, anything to the power of 0 is 1. Now the last thing we took from last video that will be really important is when I have anything to a negative power, you make a fraction where 1 is the numerator and that number is the denominator. So if I have a to the power of minus n, that just gives me 1 over a to the power of n. And yeah, that is all as a revision from Indices 1. Now let's move on into Indices 2. So the first thing we're going to be taking is fractional indices, and that's when a number is to the power of a fraction. So if I have 16 to the power of a half, what do we do here? So 16 to the power of a half basically means is when I have a number to the power of a fraction, all you need to do is you take the denominator and you put that as a root of the number. So over here I take this 2 and then I put that as a root of 16. So all this gives me is 2 root 16, which is going to give me 4. And that is my final answer. So if I do another example such as 27 to the power of a third, all we need to do over here is we take the denominator, which is 3, and then we write it as a root. So it's just 3 root 27, which is just going to give me 3. As you know, 3 cubed gives me 27. So if I have kind of a more complicated one, such as 32 to the power of minus 1/5, all this really means is, since we have a negative power, we just put it as a fraction where it's over 1, so it's 1 over 32, and then this power comes back in, so 1 over 32 to the power of a fifth. And then what we do here is we take the denominator and make it as a root. So it's just 5 root 32. 5 root 32 is 2, and then we have to put it over 1 because it is a negative indices. So my final answer is 1 over 2, so a half. So a basic general equation when we have something to the power of fraction is just a to the power of 1 over n is just equal to the nth root of a, and that is the equation. Now, if you've noticed, every single example I've done, including this equation, when the fraction is the power, 1 over here has been my numerator. Now, what if this isn't actually the case? What if the numerator is not 1? So let's go ahead and look at an example of this. So if I have, for example, 8 to the power of 2 over 3. Now, we can't use our previous equation because the numerator is 2. It's not 1. So what do we do here? So the first step is nothing special. we do the same thing where we take the denominator and make it a root of the number. So step 1 is just to take the denominator and make it a root of 8. So the cube root of 8 is 2, because 2 cubed is 8. And now that I have this number over here too, this numerator goes back in and turns into a power. So my step 2 is the numerator now turns into a power. So it's going to be 2 to the power of 2, which is just 2 times 2, which is 4. And that is my final answer. So similarly, when I have the same question but it's a minus fraction, same thing, we just do first, because it's a negative power, we just put it over 1. So I have 1 over 8 to the power of 2 over 3. And then you just do 8 to the power of 2 over 3 from there. So you get 1 over 4. And these are your final answers. So let me do one more example, such as, let's say, 125 to the power of 4 over 3. So, step 1, we take the denominator, which is 3, and make it a root. So I have the cubed root of 125. The cubed root of 125 is 5, as 5 times 5 is 25, and 25 times 5 is 125. And then step 2 would be to take my numerator and make it a power now. So my 5 over here turns into 5 to the power of the numerator, which is 4, and then 5 to the power of 4 is 625. And this is my final answer for 125 to the power of 4 over 3. So when you're answering questions with fractional indices, I highly recommend that you know your powers. So for example, know that 3 to the power of 1 is 3, to the power of 2 is 9, to the power of 3 is 27, and then to the power of 4 is 81. 4, let's say you have to know 4 to the power of 3 is 64. You have to know 6 to the power of 3 is 216. Just in general, memorize your powers. And yeah, and that's all for fractional indices. Let's go ahead and go over some questions. Okay, so have a go at these 3 questions. If you're going to answer them, pause the video from now, because I will answer them right now. So for the first question, I have 64 to the power of a half. So as we said, when I have it to the power of a fraction, the first thing to do is I take the denominator and make it as a root of the number. So this just turns into the square root of 64. The square root of 64 is 8, so therefore my final answer is 8. For the second question, I have 100 to the power of 5 over 2. So step 1, take the denominator and make it as a root of the number. So I have square root of 100. Square root of 100 is 10. And now we're not done yet. I still have this numerator 5, and then that's going to turn into a power of that number. So it turns into 10 to the power of 5. 10 to the power of 5 is essentially 10 times 10 times 10 times 10 times 10. We'll count how much zeros. 1, 2, 3, 4, 5. So it's just going to give me 1, 1, 2, 3, 4, 5. I can't fit it. Wait. 1, 2, 3, 4, 5. That is 100,000. And yeah, 100,000 is my final answer. And then for the last one is a very simple question. It's just a case where we're multiplying indices together. So when we're multiplying indices together, we add the powers. So it's just a half plus 1.5. If you know your fractions, if you know how to add your fractions, this just should give you 2. So my final answer is x squared, or x to the power of 2. And now we've officially finished fractional indices. Okay, so the next thing we're going to be taking is exponential equations. Now, exponential equations, in my opinion, is really easy, and so far the only thing we've learned right now is all about numbers, where it's to the power of a fraction. Now we're gonna take stuff where algebra is involved, and this is why the topic of indices is in algebra and not in numbers. So, what are exponential equations? Exponential equations is when I have two bases and a specific power equal to each other, but they're not exactly the same base. So I need to find what the power is. So an example is I can have 2 to the power of n is equal to 64. And the question would ask me to solve for n. Now this is a pretty easy question. So the first thing I'd obviously do is just write 64 as a power of 2. So when we're doing questions like these, it is very important to make both bases the same. That is the top priority in exponential equations. Both bases must be the same. So the first thing is I would look at this 64. 64 is obviously bigger than 2. So whatever number is bigger, I would try to turn that into the other number. So we're trying to turn 64 into 2. So we just write 64 as a power of 2. So 64 is just equal to 2 times 2 times 2 times 2 times 2 times 2. And if you count all these 2's, we have 6 2's. So 64 is just 2 to the power of 6. So I've now written this 64 as a power of 2. So 2 to the power of n is equal to the power of 6. And now it's easy. What is n? N is obviously 6. And that is my final answer. Now obviously it gets a lot harder from there, but let's just start simple. So let's do another example such as 3 to the power of n is equal to 1 over 81. Oops, let me rewrite that. 1 over 81. And then it's asking me to solve for n. So what can I do here? So again, our main objective is to make both bases the same. So what I can do is I can try to make this 1 over 81 as a power of 3. Now, I know that I just said that I should make the bigger number into the other power, but in this case, we want them both to be not a fraction, like one integer. So 1 over 81 as a power of 3. So if I have 1 over 81, this just gives me 1 over 3 to the power of 4. Because 3 times 3 times 3 times 3 is 81. So now I've wrote 1 over 81 as a power of 3. So 3 to the power of n turns into 1 over 3 to the power of 4. Now the common mistake people would think automatically, oh, n is just 4 right away. Obviously this is wrong because it is a fraction. Now this fraction over here should tell you something. Where else do we see fractions like this, where 1 is the numerator and the number is the denominator? It is negative. When the powers are negative, it turns into a fraction. So n is just 3 to the power of 4, but negative, because it's a fraction, where 1 is the numerator and that number is the denominator. So n is, instead of it being 4, it's minus 4. And that is just the final answer. Now we can check this. So if I have over here in the corner 3 to the power of minus 4, that just gives me 1 over 3 to the power of 4, which is 1 over 81. Therefore, n is equal to minus 4. Now let's look at some examples where n isn't by itself. So the following examples I'm going to show you is basically where n is being added with a number or being multiplied. So if I have, for example, 5 to the power of n, 5 to the power of n plus 1 is equal to 125. So this is simple. This is nothing really hard. Now, the first thing to do is basically just, for now, ignore this plus 1. Pretend you just have 5 to the power of n is equal to 125. Now, this is easy. Like we said, all we need to do is we need to turn this 125 into a power of 5. So 125 is just equal to 5 times 5 times 5. So it's 5 cubed, or 5 to the power of 3. So 5 to the power of n is equal to 5 to the power of 3. And now is when the plus 1 is revived. So now we have 5 to the power of n plus 1 is equal to 5 to the power of 3. So therefore, this just means that n plus 1 is equal to 3. And then it's easy. You just find n from there. So you subtract 1 from both sides. Therefore, you get n is equal to 2. And that is your final answer. So let's do another example, such as 2 to the power of 2 and minus 1 is equal to 32. So just the same exact thing here like we do every single time. We're trying to make the bases the same. So I can turn this 32 into a power of 2. So 32 is equal to, it's just equal to 2 to the power of 5. It's just 2 times 2 times 2 times 2 times 2. You get 2 to the power of 5. So I have 2 to the power of 2 and minus 1 is equal to 2 to the power of 5. And now you just ignore the 2's. All you do is just find n from there. So since they are both the same base, that means the indices are the same, because there's an equal sign here, obviously. So it's just 2 to the power of minus 1 is equal to 5. So I just add 1 on both sides. So you get 2n is equal to 6. And then you divide by 2 on both sides. Therefore, n is equal to 3. And that is my final answer. Now, the last few examples is where it gets kind of tricky. Now, if I have, for example, 9 to the power of n plus 1 is equal to 3 to the power of 5. So what we've noticed this time is the bigger number now, the larger base now, has the power of n. And we're trying to find n. So again, we want to make the base numbers the same. Now here, in this case, the base numbers are different. So all we need to do is replace 9 with 3 to the power of 2, because 9 is equal to 3 squared. But it's not that easy. I can't just say 3 to the power of 2 is equal to 3 to the power of 5, because I have this n plus 1 over here. So what this turns into is, it turns into 3 to the power of 2 raised to the power of n plus 1 is equal to 3 to the power of 5. So 3 to the power of 2 raised to the power of n plus 1 is equal to 3 to the power of 5. So what this basically means is you turn the base into the other base. And then that power it has of n plus 1, that just gets raised to a power. So 3 to the power of 2 raised to the power of n plus 1. In indices 1, we've taken that if you have a raised to the power, that means you multiply the powers. So this just turns into 3 to the power of 2 times n plus 1, which is 2n plus 2. And that is equal to 3 to the power of 5. And then you just find n from there. So 2n plus 2 is equal to 5. Subtract 2 from both sides. 2n is equal to 3, divide 2, so n is equal to 3 over 2, which is equal to 1.5. And that is your final answer for n. So let me do one more example before we move on into questions. So if I have 8 to the power of n minus 1 is equal to 2 to the power of 6. Now, what's different here? Now the bigger base has the power to the power of the n. So what do we do here? Again, the bigger base has to be equal to the smaller base. So since the base numbers are different, all we do is replace 8 with a power of 2. So 8 is equal to 2 to the power of 3. Therefore, this 8 turns into 2 to the power of 3 raised to the power of n minus 1. And that is equal to 2 to the power of 6. So we're not really doing anything hard here. We're just changing the 8 into 2 to the power of 3. And since this 8 is to the power of n minus 1, it's just the same thing here. This 2 to the power of 3 is also raised to the power of n minus 1. All we're really doing is just making the bases the same. And then we just find it from there. So again, now that the indices are raised to the power, we just multiply them together. So it's 2 to the power of 3 times n minus 1. So it's 2 to the power of 3n minus 3. And that is equal to 2 to the power of 6. And then you find n from there. So 3n minus 3 is equal to 6. Add 3 on both sides, you get 3n is equal to 9. Divide by 3 on both sides, n is therefore equal to 3. And that is the final answer. And now we've officially finished indices 2. We finished fractional indices, and we finished exponential equations. Now let's move on into some questions. Okay, so here are 3 questions. Feel free to have a go at them. If you're going to answer them, pause the video from now because I will answer them right now. Okay, so question number 1. I have 10 to the power of n is equal to 1 over 1,000. So we're trying to make the bases the same. So the first thing I would do is to try to make this 1,000 over here into a power of 10. So 1,000 is essentially 10 cubed, or 10 to the power of 3, as 10 times 10 times 10 is 1,000. So all of this turns into 10 to the power of n is equal to 1 over 10 to the power of 3. Now again, where in indices where I have 1 as the nominator and the number as the denominator, where it's a fraction. That's right, it's negative indices. So essentially, this is just n is equal to this number, but negative because it's a fraction. So it's n is just essentially minus 3. And that is my final answer for n. So question number 2. I have 125 to the power of x is equal to a 5. Is equal to 5. So all we need to do is make the bases the same. So how can I turn 125 into 5? Well, 125 is essentially just 5 to the power of 3, as 5 times 5 is 125. So 5 to the power of 3, and then since I have this x over here, it gets raised into a power of x is equal to 5. And all of this is just equal to 5 to the power of, and 5 alone is just 5 to the power of 1. So 5 to the power of 3 raised to x is equal to 5 to the power of 1. So let me just erase the question so I have space. Now since we're raising to the power, it's just 5 to the power of 3 times x. So it's just 3x is equal to 1. So x is just a third. And that is my final answer. Now for the last question, I have 64 to the power of half is equal to 2 to the power of n. So What I would do in this case is, since I have a fractional indices, I would actually go ahead and expand. So 64 to the power of half, we stated that we just make the denominator a root, so it's just 2 root 64. Now since the denominator is just 1, all we need to do is just do square root 64. Square root 64 is equal to 8, so this 64 to the power of half turns into 8 is equal to the power of 2 to the power of n. 8 is just 2 cubed, so 2 cubed is equal to 2 to the power of n. Therefore, n is equal to 3. And that is the final answer. And we've efficiently finished indices 2. I hope you guys understood this video. Please make sure to comment down if you have any questions or worries. And have a good day. Goodbye.